In this video, let us solve the question number 4 of exercise 8.3, which is taken from the chapter An Introduction to Trigonometry. The question is, prove the following identities where the angles involved are acute angles for which the expressions are defined. There are 10 expressions. We have to prove LHS is equal to RHS, like that. Now let us solve the first question. That is, the first question is cosecant theta minus cot theta the whole square is equal to 1 plus cos theta over 1 minus cos theta. Now the LHS is cosecant theta minus cot theta the whole square. Now let us convert cosecant theta and cot theta in terms of sine and cos ratios. Cosecant theta is 1 over sine theta, cot theta is cos theta by sine theta. So that is equal to 1 over sine theta minus cos theta by sine theta the whole square. The LCM is sine theta. In the numerator we have 1 minus cos theta. Now let us separate numerator and denominator. 1 sine square theta is the denominator. 1 minus cos theta the whole square is the numerator. Now we can write sine square theta as, let us keep the numerator as such, denominator. Sine square theta is equal to 1 minus cos square theta. According to the identity, Pythagorean identity, cos square theta plus sine square theta is equal to 1. So 1 minus cos square theta is equal to sine square theta. Now we have 1 minus cos theta the whole square upon 1 minus cos square theta. Let us keep the numerator as such. Now let us split the denominator by using the formula a square minus b square, that is equal to a plus b into a minus b. So now let us write the denominator as 1 plus cos theta into 1 minus cos theta. So now 1 minus cos theta in the numerator and 1 minus cos theta in the denominator can get cancels. What we get? In the numerator 1 minus cos theta, in the denominator 1 plus cos theta. So now we got 1 minus cos theta over 1 plus cos theta, which is equal to RHS, hence proved. Now let us solve the second question. The question is cos A upon 1 plus sin A plus 1 plus sin A upon cos A is equal to 2 secant A. We have to prove it. So the LHS is cos A upon 1 plus sin A plus 1 plus sin A upon cos A. Now let us have LCM, that is 1 plus sin A into cos A. In the numerator we have to multiply both numerator and denominator with the cos A here. Here sin 1 plus sin A. So in this we have cos A into cos A, that is cos square A, plus 1 plus sin A the whole square. Now cos square A, expand this one, 1 plus sin A the whole square, by using the identity a plus b the whole square. So 1 square is 1, sin square A, that is sin A the whole square, that is sin square A, plus 2 sin A. Now you can observe that here is cos square A, here is sin square A. So now we can have 1 plus this 1 plus 2 sin A in the numerator, in the denominator 1 plus sin A into cos A. So now we have 1 plus 1 plus 2 sin A upon 1 plus sin A into cos A. So in the numerator 1 plus 1, what it is? 2. 2 plus 2 sin A in the numerator. We can take 2 outside. 2 is common here. So now 2 into 1 plus sin A. Here 1 plus sin A in the numerator and in the denominator can get cancelled. So now we have 2 upon cos A, which is equal to 2 into 1 by cos A, that is equal to 2 secant A. That is RHS, hence proved. Now let us solve the question number 3, that is tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta is equal to 1 plus secant theta into cosecant theta. Here is a hint. Write the expression in terms of sin theta and cos theta. Otherwise it is also difficult. As such we can't solve it. We can't see any Pythagorean identities here, isn't it? And also we can't see, if we take LCM also it will be cumbersome. So anyhow they have given a hint. Otherwise also we have to convert it into sin theta and cos theta. Now the LHS is tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta. It is the LHS. Now let us convert tan theta in terms of sin theta and cos theta. Tan theta is equal to sin theta upon cos theta over 1 minus cot theta is cos theta over sin theta plus cot theta is cos theta upon sin theta. If you won't remember, bring magical hexagon and recollect your memory. Okay. Upon 1 minus tan theta is what? Sin theta over cos theta. We can't do anything in the numerator. In the denominator we can take LCM. So in the next step we shall write sin theta over cos theta as such upon 1 minus cos theta upon sin theta. What is the LCM? Sin theta is the LCM. 1 is sin theta over sin theta. So sin theta minus cos theta in the numerator upon sin theta. It is in the denominator. Plus here also write cos theta over sin theta as such upon 1 minus sin theta over cos theta. The LCM is cos theta. So cos theta minus sin theta over cos theta. Now we have sin theta over cos theta upon sin theta minus cos theta upon sin theta plus cos theta over sin theta upon cos theta minus sin theta over cos theta. Now let us take the reciprocals of the denominator and multiply to the numerator. So now we have sin theta over cos theta into sin theta goes to the numerator and sin theta minus cos theta in the denominator. So sin theta upon cos theta into sin theta by sin theta minus cos theta plus this sign. Here also cos theta upon sin theta into cos theta upon cos theta minus sin theta. Now let us multiply the numerators, this and this, this and this, and also denominator. Sin theta into sin theta, what do we have? Sin square theta upon cos theta into sin theta minus cos theta plus this sin cos theta into cos theta, that is cos square theta, upon sin theta into cos theta minus sin theta. So now we have sin square theta upon cos theta into sin theta minus cos theta plus cos square theta upon sin theta into cos theta minus sin theta. Observe denominators. Here sin theta minus cos theta is there. Here cos theta minus sin theta is there. If we take negative sign outside, here we will have sin theta minus cos theta. So now let us write this expression as such, plus this one cos square theta upon negative of sin theta into sin theta minus cos theta. This is an important step. Please be careful while changing the sign. Now we can take LCM, isn't it? What is LCM? Now we can change sign of this one. We will move this negative sign here. How? Let us see. Before it will be like that, same only. This negative sign, here is negative sign, moved here, it became what? Negative. This is also important step. Now we have sin square theta upon cos theta into sin theta minus cos theta minus cos square theta upon sin theta into sin theta minus cos theta. Here we can take LCM. What is the LCM? Sin theta into cos theta. Here sin theta, let us take sin theta, let us take cos theta, into sin theta cos theta. Here the same expression is there. So sin theta into cos theta into sin theta minus cos theta in the numerator. This is what we have to multiply sin theta and this sin theta, because LCM sin cube theta cos square theta into cos theta. This is same for both, isn't it? Cos square theta into cos square theta, that is cos cube theta. Observe the numerator. It is in the form of a cube minus b cube. So now we have the denominator will be the same. Let us change the numerator according to the formula. That is a cube minus b cube is equal to a minus b into a square plus b square plus ab. Here a is sin theta, b is cos theta. So now we have sin theta in minus cos theta into sin square theta plus cos square theta plus sin theta cos theta. Here sin theta minus cos theta in the numerator and denominator get cancelled. So now this is equal to, here observe sin square theta plus cos square theta. What it is? It is 1 according to the Pythagorean identity, plus sin theta cos theta. In the denominator, sin theta into cos theta. So now we have 1 plus sin theta cos theta upon sin theta cos theta. So now let us separate this and this. Okay. What it becomes? 1 upon sin theta into cos theta. Sin theta plus sin theta cos theta upon sin theta cos theta. Here 1 upon sin theta is equal to cosecant theta. 1 upon cos theta is secant theta. Sin theta over cos theta upon sin theta over cos theta is 1. Now let us rearrange. 1 plus secant theta into cosecant theta. That is RHS, hence proved. Now let us solve the fourth question, that is 1 plus secant A upon secant A is equal to sin square A upon 1 minus cos A. Hint has been given, simplify LHS and RHS separately. This is comparatively very easy question. Now let us have the LHS. 1 plus secant A upon secant A. What can we do? Now let us separate. 1 upon secant A plus secant A upon secant A plus secant A upon secant A. 1 upon secant A is cos A, isn't it? They are cos and secant are reciprocal ratios. Plus secant A upon secant A is 1. So this is LHS, final result of LHS. Let this be equation let this be 1. Now let us have RHS, which is equal to sin square A upon 1 minus cos A. We know that sin square A plus cos square A is equal to 1, isn't it? If you can't remember, have magical hexagon and write this one. Okay, so we can rewrite sin square A as 1 minus cos square A. So denominator will be the same. In the numerator, we can 1 minus cos square A. The numerator is in the form of a square minus b square, which is equal to a plus b into a minus b. So we can rewrite the numerator as 1 plus cos A into 1 minus cos A. The denominator will be same. The numerator is 1 plus cos A into 1 minus cos A. Here 1 plus cos A and 1 minus cos A and 1 minus cos A in the numerator and denominator get cancels. So now we have 1 plus cos A or cos A plus 1. Both are same. Let this be equation number 2. From 1 and 2 we can say that LHS is equal to RHS, hence proved. Now let us solve the fifth question, that is cos A minus sin A plus 1 upon cos A plus sin A minus 1 is equal to cosec A plus cot A. Using the identity cosec square A is equal to 1 plus cot square A. What is the LHS here? Cos A minus sin A plus 1 upon cos A plus sin A minus 1. We have to prove that it is equal to cosec A plus cot A. By using the identity cosec square A is equal to 1 plus cot square A. How to get cosec and cot ratios here? By dividing the numerator and denominator by sin A. For example, cos A by sin A. What it is? It is cot A. Sin A by sin A is 1. 1 by sin A is cosec A. So now let us divide both numerator and denominator by sin A. So that is equal to, in the numerator, cos A by sin A minus sin A by sin A plus 1 by sin A. In the denominator, cos A by sin A plus sin A by sin A minus 1 by sin A. So this is equal to, in the numerator, cos A by sin A is cot A minus sin A by sin A is 1 plus 1 by sin A is cosec A. In the denominator, cos A by sin A is cot A plus sin A by sin A is 1 minus 1 by sin A is cosec A. We have to prove that it is equal to cosec A and cot A. We have cosec A here, cot A here. These things are extra things. Somehow we have to eliminate them. They have given us a clue that we can use the identity cosec square A is equal to 1 plus cot square A. So instead of this one, we can use cosec square A minus cot square A. Instead of 1, let us use cosec square A minus cot square A. Now let us replace 1 in the numerator with cosecant square A minus cot square A. Now let us rearrange the terms of the numerator. First let us write cosecant A, then cot A plus cot A minus, then cosecant square A minus cot square A. Let it be in the bracket. Let the terms in the denominator be the same. Now that is equal to, these terms be same. The expression in the bracket can be written as cosecant A plus cot A into cosecant A minus cot A, because by using the identity A square minus B square is equal to A plus B into A minus B. Observe the numerator. Here cosecant A plus cot A is common. Now let us take it outside. Inside the bracket we have taken this one outside. So 1 minus cosecant A minus cot A. In the terms of the denominator will be the same. Now let us take out the bracket. What will happen here? Minus cosecant A plus cot A. Minus into minus, that is plus. The terms of the denominator will be the same. Here observe that 1 minus cosecant A minus cosecant A plus cot A plus cot A. So this and this can get cancelled. We have now left with cosecant A plus cot A, which is equal to RHS, hence proved. The example 12 of the textbook is also a similar problem. You can solve it on your own. The problem is, prove that sin theta minus cos theta plus 1 upon sin theta plus cos theta minus 1 is equal to 1 upon secant theta minus tan theta using the identity Secant square theta is equal to 1 plus tan square theta. Now let us solve the question number 6, that is square root of 1 plus sin A upon 1 minus sin A is equal to secant A plus tan A. What is the LHS here? Square root of 1 plus sin A upon 1 minus sin A. Whenever we see such problems, means under root problems, we have to rationalize the denominator. So now let us rationalize the denominator. What is rationalizing factor? In the denominator we see 1 minus sin A. So 1 plus sin A is the rationalizing factor. So now let us multiply both numerator and denominator with 1 plus sin A. Now what happens? In the numerator we see 1 plus sin A into 1 plus sin A. So in numerator we have 1 plus sin A the whole square. Here 1 minus sin A into 1 plus sin A plus B into A minus B, that is equal to A square minus B square, that is equal to 1 minus sin square A. Both are under root. So that is equal to under root 1 plus sin A the whole square upon 1 minus sin square A. Here in the denominator we have 1 minus sin square A. By Pythagorean identity we have sin square A plus cos square A is equal to 1. So 1 minus sin square A is equal to cos square A. So now we have square root of 1 plus sin A the whole square upon cos square A. Since both numerator and denominator have squares, now we can cancel this square with under root, this square with under root. So now we have what? 1 plus sin A upon cos A. Now we can separate like this. 1 by cos A plus sin A by cos A. So that is equal to 1 by cos A plus sin A by cos A. What is 1 by cos A? It is the reciprocal ratio of what? Secant A. So that is equal to secant A plus what is sin A by cos A? This is tan A. So now we have secant A plus tan A, which is equal to RHS, hence proved. Now let us solve 7th question, that is sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta is equal to tan theta. So the LHS is sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta. In the numerator sin theta is common, in the denominator cos theta is common. So now the LHS is sin theta is common in the numerator, 1 minus 2 sin square theta. Cos theta is common in the denominator, so 2 cos theta into 2 cos square theta minus 1. Observe this part, sin theta upon cos theta. What is the value of it? It is tan theta. But our problem is not over here. Either if we write denominator as 1 minus 2 sin square theta or numerator as 2 cos square theta minus 1. Our problem will be over. How can we do this? Either we can convert sin square theta into 1 minus cos square theta or cos square theta into 1 minus sin square theta. Now let us retain the numerator as such and convert the denominator. So let us convert cos square theta into 1 minus sin square theta. Put the bracket correctly. Minus 1. Now let us remove the bracket here. Simplify this one. And let us retain all the other things. 2 into 1 is 2. 2 into minus sin square theta is minus 2 sin square theta minus 1. Now let us simplify this part. So that is equal to 2 minus 1. That is 1. 2 sin square theta. So this and this can get cancelled. Now we have sin theta over cos theta, which is equal to tan theta. That is RHS, hence proved. Now let us solve the 8th question, that is sin A plus cosecant A the whole square plus cos A plus secant A the whole square is equal to 7 plus tan square A plus cot square A. This is an important question since it appeared many times in previous year question papers. So practice it well. Okay, what is LHS here? Sin A plus cosecant A the whole square plus cos A plus secant A the whole square. Now we can use identity A plus B whole square and expand it. Here also we can expand it by using the identity A plus B the whole square. Now let us expand this one, sin A plus cosecant A the whole square. Sin A the whole square is sin square A. Cosecant A the whole square is cosecant square A. 2 into sin A into cosecant A. Plus cos A the whole square is cos square A. Secant A the whole square is secant square A. Plus 2 into cos A into secant A. Now let us remove the brackets. Here observe that sin square A plus cos square A is equal to 1. Let us keep in mind it has been solved. We have to get some numbers here. Then observe that sin A and cosecant A are reciprocal ratios. We can cancel them. Then we will get 2. Or we can replace cosecant A by what? 1 by sin A. So we can cancel this and this. Now we have 2 here. Here also cos A and secant A are reciprocal ratios. We can cancel them, or we can replace secant A by 1 by cos A. Now we can cancel this and this. Now we have 2 here. 1 plus 2, 3. 3 plus 2, 5. We have to get here 7 and tan square A and also cot square A. Observe cosecant square A. It is not mentioned here anywhere in RHS. So now let us replace cosecant square A by what? 1 plus cot square A. You know it is a Pythagorean identity. 1 plus cot square A is equal to what? Cosecant square A. Similarly, let us replace secant square A by what? 1 plus tan square A. Now, up to 5 we have got, isn't it? 5 plus 1, 7. 7 plus 1, 5 plus 1, 6. 6 plus 1, 7. We got 7 here. Okay. Then there is tan square A and cot square A. So that is equal to 7 plus tan square A plus cot square A, which is equal to RHS. Hence proved. Here plus. Here we have to multiply with the cos A. So plus cos square A. So this is equal to, here if you observe, what will you get? According to Pythagorean identity, sin square A plus cos square A is equal to 1, isn't it? So this is equal to, here instead of sin square A plus cos square A, let us write 1. Now we have to take the reciprocal of the denominator. What is it? Sin A into cos A. So this is equal to sin A into cos A. Let this be equation number 2. From 1 and 2, LHS is equal to RHS. Hence proved. Now let us solve the 9th question, that is cosecant A minus sin A into secant A minus cos A is equal to 1 upon tan A plus cot A. Hint has been given, simplify LHS and RHS separately. So now LHS is cosecant A minus sin A into secant A minus cos A. If you observe LHS, you can convert cosecant A and secant A in terms of sin and cos ratios, isn't it? Now let us convert cosecant A into 1 by sin A. Secant A is 1 by cos A. Now let us have LCM of this part. This is sin A by 1. So sin A is LCM here, that is, and in the numerator 1 minus here sin square A. Why? You have to multiply both numerator and denominator by sin A. So in the numerator, what? 1 minus sin square A. Similarly, this part, the LCM is cos A. In the denominator here, 1 will be there. So 1 minus cos square A. Now let us multiply these two. Observe, in the numerator, what will you have? 1 minus sin square A means what? Cos square A. Here 1 minus cos square A. What is it? Sin square A. Here cos square A, here cos A, get cancels. Sin square A, sin A, get cancels. What is remaining here? Sin A into cos A. Let this be equation number 1. Now let us solve the RHS. RHS is 1 upon tan A plus cot A. Now let us convert the denominator tan A plus cot A in terms of sin and cos ratios. So this is equal to 1 upon, instead of tan A, we have to write sin A upon cos A, plus instead of cot A, cos A upon sin A. Now we have to take the LCM of the denominator. What is the LCM here? Sin A into cos A. So now in the denominator, sin A into cos A, In the numerator, here we have to multiply sin A, isn't it? So sin square A, here plus. Here we have to multiply with the cos A. So plus cos square A. So this is equal to, here if you observe, what will you get? According to Pythagorean identity, sin square A plus cos square A is equal to 1, isn't it? So this is equal to, here instead of sin square A plus cos square A, let us write 1. Now we have to take the reciprocal of the denominator. What is it? Sin A into cos A. So this is equal to sin A into cos A. Let this be equation number 2. From 1 and 2, LHS is equal to RHS, hence proved. Now let us solve the question number 10, that is 1 plus tan square A upon 1 plus cot square A is equal to 1 minus tan A upon 1 minus cot A, the whole square, is equal to tan square A. Now let us take this part. If we see the problem, this part, we can clearly say that this is an identity, Pythagorean identity. This is also a Pythagorean identity. So now let us take this part. What is it? 1 plus tan square A upon 1 plus cot square A. Since both numerator and denominator are Pythagorean identity, now let us write like this. The denominator 1 plus cot square A is equal to cosecant square A. The numerator 1 plus tan square A is equal to secant square A. Now let us convert both numerator and denominator into sin and cos ratios. So that is equal to 1 cosecant square A is equal to 1 upon sin square A. In the denominator, in the numerator, secant square A, which is equal to 1 upon cos square A. So now this can be written as 1 by cos square A, denominator, take the reciprocal of the denominator, that is sin square A upon 1. So 1 by cos square A into sin square A upon 1. So this is equal to sin square A upon cos square A. What is sin by cos ratio? It is tan. So this is equal to tan square A. Let this be equation number 1. So this part is equal to this part. Now let us take this part, middle one, that is 1 minus tan A upon 1 minus cot A the whole square. Here we can't see any identity. If we convert tan A and cot A into sin and cos ratio, the problem will become cumbersome. If you take the square and expand, that is also become cumbersome. So now let us write cot A as 1 upon tan A. So this is equal to, the numerator will be same, 1 minus tan A, square also will be there. In the denominator 1 minus, let us write cot A as 1 upon tan A. Now let us take the LCM of the denominator. So this is equal to, numerator will be same. In the denominator, the tan A is LCM. The numerator of the denominator, what is it? 1 1 is 1 by 1 or tan A by tan A. So tan A minus 1. Now let us write it like this. Means tan A goes to the numerator, isn't it? 1 minus tan A upon tan A minus 1 into tan A it becomes. So this is equal to what? Square will be there. The simple thing here, tan A is written as like this, and we have taken negative sign outside the bracket here. I have put here, then it becomes 1 minus tan A. So we can cancel 1 minus tan A in the numerator, 1 minus tan A in the denominator. What is the result now? This negative sign into tan A, that is minus tan A the whole square. So this is equal to minus tan A the whole square. Minus minus. If we put 2 times it becomes positive. Tan A the whole square is equal to tan square A. Let it be equation number 2. From 1 and 2, what do we have now? Tan 1 plus tan square A upon 1 plus cot square A is also tan square A. From 1. From 2, 1 minus tan A upon 1 plus cot A the whole square is also tan square A. So this is equal to this, isn't it? First one is equal to the middle one. Hence proved. I hope you have understood the problem number 4 very clearly and also the concepts of trigonometry. Please like, share and subscribe. Thank you for watching.